we're talking about complex numbers, okay? Polynomial functions and complex zeros. So we know how to find the principal square root of non-negatives, right? Like if I ask you, what's the square root of 4? Everyone's going to say 2. Yay, you're so smart, okay? But what happens when there's a negative underneath the square root? It becomes imaginary. We get our eyes, right? When that happens, we create our eyes. Okay? So our imaginary numbers come into play. So if we recall that the square root of -1 equals I, right? So the square root of -1 equals I, which means that I squared equals what? -1, okay? So those are the main two you need to know and feel okay with is the square root of -1 equals I, and I squared equals -1. Yes? We've all seen this before. We all know this, right? All right. So the imaginary number here. So for example, if I asked you what is the square root of -9, you can separate radicals, right? You can make them into as many radicals based on the factors that they have. So if I separate this into two factors, 9 and -1, I would take the square root of 9, which gives me 3. I would take the square root of -1, which gives me I. So my answer is 3i, right? Now, to make this a better answer, it would be plus or minus 3i, correct? Okay, so that's in our brains, I promise. We have to dust off some cobwebs, but it's in there. Okay. So pay attention. We have a complex number as a number in the form of a plus bi. Do you remember that? Yes. A plus bi is when you combine when you add or subtract a real and a imaginary. They create what's called your complex. Yes? The A is always your real part, and your bi is your imaginary part. Together, they make the complex number. Okay, so the fundamental theorem of algebra guarantees that any polynomial function of x with real numbers can be factored completely over the set of complex numbers. So I can completely factor all polynomials. However, some may have complex numbers as their factors. Yes? Okay, that is what this is stating. That's all that this theorem is stating, and someone got a whole bunch of little credit for stating it. Oh yeah. Good job, person. So we're gonna start with the easy factor. Okay, we're gonna start easy. We have this cubic polynomial. How do I know it's cubic? My highest exponent is 3, so it's a cubic. And we're gonna go through and review some of our factoring techniques, right? Here we go. The number one factoring technique you should always check for is what? No. Number one. Huh? Thank you. Greatest common factor. The first thing you should always check for is your GCF. So when I look here, is there a GCF? Yes. What is my GCF? 1x. So I'm going to factor out an x from each term, right? Factoring out means that I'm dividing an x out of each term, correct? And I put it in front because, look, your parents love you. They're not kicking you out the family. They're just kicking you out the house. That's all factoring is, okay? They're kicking you out the house, but you are still loved. You can still come and visit. You can be there. You're just not inside the house with them anymore. Okay? So once I've done GCF, I then am going to try quick multiplication and ask myself, is there anything that multiplies to give me 13 but adds to give me -6? Does mental factoring work? No, mental factor fail. Womp, womp, womp. Okay? Now, because mental factoring failed, we have to do the good old. No. What's it called? We don't have to do Xbox. It's the quadratic formula, guys. That's all you needed. I don't know where y'all were going, but when this fails, when you can't do this without Xbox. You only use Xbox if mental factoring works.
I use Xbox.
Okay. You cannot, otherwise we're going to use the handy dandy quadratic formula, which is, sing it with me. X equals, oh, that didn't go well. That did not go well. Let's try that again. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Why? Why not? X equals, okay, my 8th grade teacher made us all stand up and act like we were rowing a boat. And because of that, every time we used it for a whole week, we had to stand up before using it and act like we were rowing a boat. And guess what? This never left my brain. And I can't say it normally. So every time you'd stand up. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, and then you sit back down. Okay. We actually had a smart butt kid who did that. When it was time to use it on the test, he stood up and sung the song. Yes, they're always there. All right, so now that I have this, I'm going to plug in my A, my B, and my C, and it's always in alphabetical order, correct? So we're going to plug it in. We have our A is Casper the Friendly One. We have our B is -6, and we have our C is 13. A, B, and C. So that gives us -6 plus or minus the square root of b squared minus 4ac divided by 2a. Hey, I can't stop. I cannot. It's ingrained in me. I've been doing this since I was 14. That's a long time. So,
How long ago were you 14?
A long time ago, more than half my life. Yes, I told you I want to be out since 4th grade. All right, so we have 36, and what's 4 times 13? 52? 52 minus 52 all over 2. And I'm gonna keep going. What is 36 minus 52? 16. -16, guys. Okay. Yes.
What do you do with the 4 times 1?
4 times 1 is 4. And then 4 times 13 is 52. You multiply left to right.
Oh, okay.
Yeah. All right. And then the square root of -16. 4i. Good job. So we have 6 plus or minus 4i all over 2.
Is that a C?
It's my I.
Dang. This made it look way worse. I'm not gonna lie to you.
I'm very tired of being bullied at my job.
We're not bullying you, man. We're trying to help you out.
I just wanted to make sure it didn't look like anything else. It's fine. All right. Anyways, people, what is 6 divided by 2? What is 4 divided by 2? So this is my simplified answer. 3 plus 2i.
Plus or minus.
Plus or minus 2i. I wrote the plus or minus.
Never figure out what
It's imaginary.
Yeah, what is the point of that? Why do we have to have imaginary?
Because someone said we had to acknowledge the fact that we were ignoring the square root being negative. And so they created imaginary so that the negative in the square root would be acknowledged.
Yeah, whoever that is. Yeah.
All right, guys, this was a review. Let's continue our review. All right. So, because we had a negative underneath the square root. So anytime you have a negative underneath the square root, your I is going to be, hey. Okay. All right. So, now that we have this guy, this is our complex number, right? We have the real is the 3, the imaginary is our plus or minus 2i, correct? So what this tells us is that we have two imaginary points on our graph, okay? The other thing is your greatest common factor, your GCF, that's always one of your zeros. That's what GCF is super important, is that if you have a GCF with a variable, that is a 0. A 0 at 0, which makes sense, right?
Oh,
Okay, why not?
no, it's.
Oh. So the last thing now is you can state where your zeros are. We have x equals 0. And we also have x equals 3 plus 2i. Oh, that got weird.
Oh my God.
And we have x equals
Stop.
3 minus 2i. So these are my zeros. Because my greatest common factor was a variable that I factored out. So this is always a 0 if it's a variable. If it's a 2, then that's not a variable, that's a number. So no, only if it's a variable is it a 0.
Yes.
No,
Wait, what? Variable is like the.
a variable is the x.
Variable. So if the GCF is a variable, then
There's a factor at 0. If it's just a 2, if it's just a number, it's just a GCF that factored out. So there's a difference. This right here. How can I write this? Do you guys remember seeing if I had x times x plus 2, right? And I said find the zeros. Well, when you're finding the zeros, you're taking each factor and you're setting it equal to 0.
Yeah.
So if I have a variable on the outside, it's going to always equal 0, right? Yes. So that's what when I say that's what that means, is that I have a variable on the outside. However, if I have 2 times x plus 2, this isn't a variable factor. The only factor that's going to be set equal to 0 is the one with a variable in it. So I only have 1 0 in this problem, but in this problem it has 2. And that makes sense because this is a quadratic and this is a linear. Okay? You do nothing with that 2. That's what I'm emphasizing. There's no variable attached to this 2, so you do nothing to that 2. Because 2 can't equal 0. It's just in factored form. Yep. It's just so that you can find your 0 easier. That's it. Sole purpose. All right. So how do we feel about finding the zeros, reviewing that from quadratic? Okay. Quadratic formula. Go through it. Find your zeros. Okay. Your zeros are going to become your, if you were to write this in factored form, it's just saying that I have x times x minus 3 plus 2i times x minus 3 minus 2i.
So this is how we would write the answer?
If it asks for the it said factor completely. So that's my factor completely. The what? Oh, when you can multiply is greater than 1?
Yeah.
Yes. But you can always, even if you don't want to use Xbox, this is your catch-all. The quadratic formula is going to solve it every single time. Yes. All right, review notes are taking a little bit longer than I anticipated, per usual. Per usual. Huh? Yes. So, I was going to have you guys factor example 2 on your own and see what happens. So, try number 2. Shouldn't take you long when you try it.
What if I don't try this?
Then I'll cry.